Okay, today we're going to do a few examples of solving linear inequalities. We're going to work on this simple one first, and then do one that is slightly more complex. We're also going to graph out our solutions on a number line. When you're solving these, you just want to treat it like it's a normal equation. So you can treat this inequality sign here just like it's an equal sign. And the one thing to remember is that if you ever multiply or divide by a negative number, that the direction of this sign is going to flip. Um, so if we're solving this like it's a normal linear equation, we're going to want to get all of our x terms on one side and then everything else on the other side. We're going to subtract 1 from both sides. So we're going to have negative 5x is less than, and then 4 minus 1 is 3. And then we're going to divide this entire equation by negative 5 in order to get x by itself. And remember that this sign is going to now change directions just like that because we divided by a negative. So over here we just have an x left over, and then this is going to be 3 over negative 5. So this is our solution right here, and now we just have to put it up on the number line. So if we have it's x greater than negative 3/5, and since it's just a greater than, we're going to use a open circle. If we have a symbol that looks like one of these two symbols here, we're going to use a closed circle on our number line that looks like that. But if we have a symbol just like this, we're going to use a open circle, because the solution set, when you don't include the equal to part, doesn't include the value negative 3/5. So we're going to go on our number line here and find negative 3/5. So negative 3/5 is approximately right there. So that's where we'll put our circle, and we want x to be greater than negative 3/5. So since we want x to be bigger than this number, we're going to shade in the positive direction, just like that. So that is how you solve and graph linear inequalities. So we'll do one more. It's going to be the same concept here, only we have a x on either side of the equation. So it's going to be a little bit more complicated algebraically, but it's pretty much the same thing. We just want to get all of our x's on the same side, so I'm going to subtract 3x from both sides of this equation. So 2x and subtracting 3x is going to give us a negative x over here. We still have this plus 7 greater than or equal to negative 2. So now we want to move this 7 over to the other side. So we're going to have negative x, and I'm going to subtract 7. So negative x is greater than or equal to negative 2 minus 7. So that's going to give us negative 9. And our last step is to divide by negative 1 on both sides of the equation, just so that x is by itself. So I'll go ahead and write that out. So that's what we're doing there, and since we're dividing by a negative 1, this sign here is going to have to flip. So what we're left with is x is less than or equal to negative 9 divided by negative 1 gives us just a positive 9. So this is our solution to this inequality up here. So this one has a equals to part, so kind of like our previous example, when we have these 2 equals 2 signs, we want to use a closed circle. So graphing is going to be the same, only on our graph here we're going to put a closed circle at positive 9. So that looks about right. Here we want x to be less than or equal to 9. So since x is less than, we're going to shade the area here that is less than 9. So that's our solution to that one.